Let's talk about text classification in machine learning and AI. Uh, Text classification is a fundamental task in natural language processing, that is NLP, that involve categorizing textual data into predefined category. The technique has vast applications from spam detections in email to sentiment analysis on social media platform, document categorizations, and more. And So, in terms of like uh, understanding the text classification, so let's start with you know um, tech. What is text classification? It's the process of assigning label into category of a piece of text that can be considered as supervised learning task, where the objective is to train a model to predict the correct label for the unseen text based on label training data. However, there are like certain challenges in this, like high dimensionality, where text is inherently high dimensional, requiring efficient method to represent and process. Then is ambiguity. Word phrases can have multiple meanings and dependencies on the context. And data imbalance. Certain in classes uh, 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 may have significantly more example than others, than leading to the bias. Then is dynamic vocabulary. New words or phrases frequently emerge or necessitating adaptability in the models. However, they are very important. Like it enables the automation of process like email filtering, provides insights into customer feedback via sentiment analysis, organizes a large data set, making more information retrieval more efficiently. And if we talk about the types of text classification, first one is binary classification, which classifies text into two categories, for example, spam or not spam. Then it's multi-class classification, which categorizes the text into more than two classes. For example, classifying new articles into sports, politics, and entertainment, etc. Then is multi-label classification, which assigns multiple labels to a single text, for example, tagging a blog spot as both technology and education. Then is hierarchical classification, which involves organizing text into hierarchy of categories. For example, categorizing scientific papers into subjects, subfields, and topics. And if we talk about pre-processing text for classification, we start with the text cleaning, which removes the like punctuation, eliminates unnecessary characters that do not contribute to the meaning, and lower casing, which ensures uniformity of converting all text into a lowercase. Then is removing stop words that filter out common words, for example, and that do not have value. Then is tokenization, which divides text into smaller units, that is like tokens such as words or phrases. Then lemmatization and stemming. Lemmatization reduces words to their base or dictionary form. And if we talk about stemming, it trims the words to their root form by removing their affixes. Then is handling imbalanced data set, that is like over sampling, which is duplicates minority class examples. Then is undersampling, which reduces majority class examples. And then is synthetic data generation, which uses algorithms like SMART to generate synthetic examples. And moving forward, next is feature engineering. So feature engineering starts with the bag of words, BOW, which represent text as a frequency distribution of words. Simple yet effective for many tasks. Then is term frequency inverse document, TF-IDF, It weighs words based on their frequency in a document relative their frequency across the all documents. Then word embedding, word to vec. It captures semantic relationship between words. Uh, glove. It builds words vectors based on global world or co-occurrence statistics. Then is fast act, which accents word vec by considering subwords information. Then is sentence embeddings, which encodes entire sentence into fixed length vectors. Examples like universal sentence encoder or BERT embeddings. Then is algorithms for text classification. Generally, we have like traditional machine learning algorithms, which have naive Bayes, uh, which is very probabilistic model based on Bayes theorem suitable for text classification. Then is SVM, which is super vector machines, which is very effective for high dimensional data like text. Then is logistic regression, a linear model commonly used for binary classification tasks. Then is decision trees and random forest, which provide interpretable results and handles more nonlinear data. And if we talk about deep learning techniques, we start with the RNN, which is recurrent neural networks, which is effective for sequential data but prone to vanishing gradients. Then is long short-term memory networks, LSTMs, which is which mitigates the limitations of RNN by handling long-term dependencies. Then is GRUs, gated recurrent units, similar to STMs but with a simplified architecture. Then is CNN, which is convolutional neural networks, captures local patterns in a text, often used in combination with RNNs. And then is transformers. It is revolutionized NLP by capturing contextual relationships like example like bird, GPT, robot, etc. Then uh, then if we talk about applications of text classification, it can do sentiment analysis, which determine text conveys a positive, negative, or neutral sentiment. Then is spam detection, which filters unwanted emails or messages by identifying spam. Then is document categorization, organizes document into predefined categories, enhances information retrieval. Then is language detection, which identifies the language in which the text is written. Then is chatbot and virtual assistant, which enables the uh, intent detections and response generation. And if we talk about evaluation metrics, it's like accuracy, they have precision, recall, F1 scores, and with that they have like confusion metrics and ROC AUC curve, which evaluates the trade-off between the true positive rate or false positive rate. And moving forward, if we talk about tools and libraries, so we know like Python has a lot of libraries like NLTK, which offers tools for tokenization, stemming, and more. Then spaCy, efficient for processing, feature extraction. Then scikit-learn, which provides algorithm for traditional machine learning. Then TensorFlow and PyTorch, which support deep learning models. And if we talk about cloud services, there are like many cloud services. Nowadays we have Google Cloud AI, which offers pre-trained models for text analysis. Then AWS Comprehend, um, which provides NLP services for sentiment analysis, entity recognition. Then we have Microsoft Azure Cognitive Services, which includes tools for text classifications. And if we talk about recent advances and trend, we have pre-trained models like BERT, which captures bidirectional context. Then is GPT, which specialization in text generation and completion. Then is T5, which treats NLP tasks as text to text transformation. Then few shot and zero shot learning. It allows model to perform classification with minimal label data. Then explainable AI, which is XAI. It ensures the transparency in classification results by explaining model prediction. Then as real-time text classification, it focuses on deploying models on real-time decision making in applications like spam filtering, sentiment analysis, and however, if we talk about challenges, there are like ethical concerns in biasness in the data, and in terms of scalability or the adaptability. And if it, however, in the conclusion, I can say text classification is a pivotal technique in the landscape of machine learning and artificial intelligence. As a technology evolve, so do the methods and the application of the test classification as well. However, with ongoing advancement in deep learning and the emergence of pre-trained language models, the future holds immense potential for more accurate, efficient, and explainable text classification system. Thank you for watching.